Hello. Okay, everyone's back. Cool. Let's get started. I hope you all enjoyed the last talk. I personally learned quite a lot with post-model training. Cool. This talk is more on the application layer, not on the model layer. So this is a talk about my personal learnings when I was building my existing products for a AI native platforms. So, for example, you might have lots of internal tools, your personal projects, and you might wanted to add AI capabilities into that product, and you might have also wanted to like build some bit of intelligence within that product's functionalities. So, surprisingly, the learning curve I had when I was working with the AI infrastructure was pretty interesting because I started off with the AWS platform. Then I went on to use Cloudflare, Supabase, all these tools. And now today I pretty much limit all my AI workloads with like one Postgres table. So Postgres database has completely kind of changed the way I build and look at applications. And it scales really well too, because when you are building a new application from a MVP and you are taking it all the way to users and you are scaling to like daily active users of 10,000, 50,000 users, it smoothly gave like very good performance when I was scaling. So I just wanted to give a talk about my personal learnings, how the new AI ready stack is something very simple that many of us might have already worked with. Okay, so before we start, a small intro about myself. Okay, that's weird. So my name is Danny. I'm currently working as founding engineer at Browser OS. It's a YC backed startup. So the idea behind Browser OS is a AI powered browser which acts as the web layer for your agents. Think of it like agent browser, but with your actual logged in accounts. So my area of interest is I build browsers, terminals, AI assistants, basically all the places where humans and agents meet. So the idea is I specialize in building harnesses. Right now I'm working on an AI agent brain project. And I also do a lot of open source work. So the primary product of Browser OS itself is open source. You can find it on GitHub. And the other one is Agent Terminal. This is a terminal built for AI agents. You get push notifications, callbacks, a rich experience when you run your agent within this terminal. And this is Herbie, an interesting idea. You get single UI for all the agents installed on your machine. So some people use Py, some people use open code. Herbie acts as one UI layer for all the agents, and it comes with certain benefits. For example, you can connect Telegram to agents which doesn't actually have Telegram support. And I am also actively building ACPX tools. So this lets you control other agents programmatically using the ACP runtime. I am actually leveraging a lot of work that was done for the OpenClaw project. From there, I am like extracting certain learnings and building my own tool layer on top of it. And this is Style CN, interesting project I started last week. Basically, I took shared CN and extending it to all the brand themes. It has been like pretty fun experience. So if anyone wants to like check out my open source projects, check out my GitHub profile. I'll share my profile at the end. Now, let's look at the different parts that are needed to make an app AI ready. The text is little small, it's okay, not important. We just need to look at the main areas. So the first one is authentication. This is like the very crucial layer, because once you are working with agents, data becomes a very crucial part. We have to make sure the agents have exact permissions. It doesn't leak unauthorized data. So authentication is like the most crucial part. The next one is APIs. You have to make sure your product APIs are well defined, so it's easy for the agent to discover. More like you have to make sure you have an open API spec, TypeScript types, or a GraphQL schema, something the agent can read and understand how the API layer works. Then you need to store a lot of structured data. And you will also need to store a lot of unstructured data. For example, let's say your agent is like making a lot of tool calls, and it's also doing a lot of reasoning text. These are all like data that you might not need to process, but you might need for auditing and governance purposes, like what the agent has done, like tracing and all those. Then from there, you will need a lot of queues. So background jobs, cron jobs, all these activities like indexing data at real time. So you generate embeddings. Then you need the search. This is the RAG part, basically where you use the text search, embedding search, vector search, all of these layers. So your agent gets the data back efficiently. So let's say you have like three projects running in your application and you want the info from the project you built 2 days back. This search layer is very crucial to get those context back. Next, type safety. So type safety, basically it's everything. You have MCP, you have CLI, you have APIs. All of them should have like well-defined types. So agent doesn't pass a string to an argument that requires number. Lastly, real-time updates. So these are all like status that you show to your agents. Like an agent is streaming and it has started a background job, and the job has to come back and immediately notify your application that the job is done. So any kind of like immediate updates that you want to like show to your agents. So I have kind of shown like 8 concepts from like authentication, data storage, search, queues, type safety, and real-time updates. Previously, we used to like build something like this, like one deployment with like different layers. Like you have HTTP request, SQL queries, then you have a middleware that does auth checks. You build REST handlers like any express route or like a GraphQL resolver. Then you build a job layer, WebSocket, background worker. So kind of your monolith starts piling up. It starts increasing in size, and your control and the moving parts also start to increase. So at some point you will get a log like this. Like some part of your service like starts to fail, start to disconnect, and to fix that you will have to like bring the entire application down to make sure all the updates go one by one back into the app. Then we tried microservices, like any regular developer. Like we just decided, yeah, if there is one point of failure, let's expand it and create multiple points of failure. Now this became a headache because once your auth service is out, your points of failure start to increase. Like now you have to make sure every new service you are building knows how the auth service works. I'm using the right token, right access rules, access policies. Also, we used to maintain a MongoDB database, and we also had a Pinecone database. So we had to maintain multiple databases and we had to sync data between them. And queue and real time, there were like AWS SQS. Then we moved to Cloudflare queues. There is like a lot of process that jumped around. These are like too much for an internal tool or like experiments that I was building personally. So for a company, like you have lots of customers, this will scale really well because you have individual teams maintaining each layer. But when I was trying to build a quick idea or a quick prototype, and I want to immediately take that prototype to the market, these are all starting to become a huge bottleneck, because the agents can code well, but when you give multiple infrastructure to the agents, automatically it starts to struggle, starts to like show its weaknesses. Like if it's simple code or like simple function, it does job really well. Otherwise, I have to hop in for every change, and my infra file also starts to increase. You get like a Docker Compose file, you have a Wrangler file, you have a CDK. It's just pretty huge. So that's where my search for a simpler alternative started. So my idea was Postgres had a lot of plugins initially. When I was working with Supabase, I knew Supabase was just a Postgres database. They had like GraphQL functions and Supabase functions, GraphQL endpoints. They had a lot of this interesting things. So I wanted to understand how Postgres works. Why is it like used by Supabase to build all these services out? Turns out Postgres is not just a regular database. It actually was designed as a platform that can do transactional actions. So as we go, I'll explain how this thing plays out. But Postgres had a lot of interesting plugins and an ecosystem built around it. So the idea is you use it as a database, but when you need an additional function, you slowly extend it. You provide like additional plugins, additional tools. So first thing, there are three vital pieces. So first one, it was catalog driven. So the idea behind catalog driven is all the data in Postgres had a well-defined type. You have index type, you have a function type, you have a number type, you have a JSON B type. So everything is cataloged and well-defined. This means any new Postgres function I build on top of this table, they have clear understanding of what's the data, the underlying data they are working with. Next, it's a one transaction system. So always there will be a write and there will be a schema change, and you can actually get a clear notification on what was written and what was the change that we received. And this all shared an atomic boundary. So when I get a notification that a write has been completed, I can be sure 100% that the write is complete. There is no worry about the write being like a failure or error doubt. There is no such scenario. It was very reliably built. And it also made sure building like jobs and everything are automatically more reliable, because job, the biggest problem is how will you retry? How will you track the errors? How does job failure or success scenarios work? So then WAL, so this is write ahead log. This becomes a universal log. So how many people here used Postgres before? Okay, how many people can explain what's a WAL? No one? Okay, what does a write ahead log do? Yeah. So any operation that happens on the database, it actually tracks if the operation is successful, if it is done, and once it is done, it creates a record. That record is actually the data that we see in Postgres, that a table gets inserted or a table gets edited. So everything is technically a log that is stable and durable. So in that scenario, any type of crash, any type of like replication issues across shards, you can be sure that the write ahead log will be preserved. So you will have proper durable data across the database. Now on top of this, a large ecosystem of tools started to rise. So the first thing, remember what I said when I was working and was building an AI ready application. The most important part for me was authentication. I have to be very careful that I don't leak another company's data into a different company's agent. Correct? And usually, how do you guys do the authentication? Can someone like, pardon? Login credentials. And can you explain the flow, how the login credentials protect your data?
Basically, you first log in, you enter your username and password, and then it asks like validation, like it asks for like go to your email and
So
every company has its own domain. You need to validate the domain and redirect to the according domain.
got it. You guys will issue a token, correct? Every time you authenticate. Yeah. You basically like check if the token is valid, the token has the right ID, and then you query the database for that specific ID, targeted user ID. See, okay, this user ID's token is valid. Let me query this user ID. And how do hackers usually like target their attacks? Or any kind of mistake happens, how do those mistakes usually happen? Usually when the ID gets confused, let's say even if the token passes, your application is reading the ID at some point, instead of comparing with the right ID, it uses an incorrect ID. The data, it will retrieve the entire incorrect data back. So this is the traditional authentication system. And surprisingly, Postgres has an interesting authentication system called row level security. How many people heard of this RLS? Are you guys using Supabase? No? Yes, okay. RLS is a very interesting security model in Postgres where when you create a table, you assign certain roles and permissions to that table. Then what happens is, if an application starts with the right permission, it can only see the data it has access to it. So even if any IDs or values get confused, it cannot access the data it's not supposed to. Let me show you how it works. So right now, I was actually building a local tool for searching code base. I used that tool as an example for this talk. So you will see me referring a lot of the tables similar to this. Is the text visible, everyone? Okay, so right now the team ID for the files is the tenancy key. So there are lots of files and I have to make sure only each file is associated with a specific team. Then I add a RLS on that table. So files now has row level security. Then what I'll do is I'll create a policy here saying anyone who accesses this files table, create policy files team on files, their team ID should be set on the application's team ID context. So the idea is anyone who wants to access this table should have a team ID set. And only after they have the team ID set, they can actually view the table. So let me actually show this in action, because when you look at it with the code, it looks a bit confusing. So I prepared a demo. I hope the demo runs, because SQL gets a little confusing. I took some notes and all. Let's see how it goes. Is this mic working? Okay. Hopefully this works. Let me show you guys. So this is the authentication file. Let me quickly spin up the Postgres setup. Is the Docker down? Yep. Okay, I'm just spinning up a new Postgres instance. All right, the terminal text is visible to everyone, right? Okay, so this is my Postgres instance. And within this, I have the files table. So this is my files table and it has certain columns. So let me just select this first. Select count star from files. You can see it has 6 rows. Let me also select some columns. Repo ID. Content from files. So you can see it has some repo ID, and content is just like a set of code block. So this is an app I created for browsing and maintaining my application repo source code. So you will see a lot of code like this. Let me remove the content. Let me just show the repo ID. So there is like 6 repositories. The last repo is different. Now here is the interesting part. I already enabled row level security on this table. So I already have the RLS policies enabled for teams and files. So now what happens here is I'll set a role app. So right now I am in root access. I have access to all the tables. Now I am setting the role to app. Now if I go and try to find the files, it will say I have 0 rows, because I am on the application role, and the application currently doesn't have a team ID set. So without the team ID, it's impossible for me to get the data. So even if I have the right token or right incorrect token, either way, Postgres refuses to show me these rows. So how do I get this token? First, I have to create a transaction here. Here I'll set a local variable app.teamid, and this is a team ID I took from the table. And once I set the team ID and count the files, you'll see I have 5 items accessible to me, but in original we had 6. Now all the tables that are accessible to me are only visible for me, so I can extend it to like do any kind of queries. For example, uh, this is an insert into an incorrect team. So I am, see what happens when I try to insert into an incorrect team. You'll see new row violates the row level security policy. You can only insert to the team you are associated with. It's impossible to make a mistake like this. Usually this kind of mistakes don't happen because we are careful when we are coding. But when you are working with AI agents, these are the kind of mistakes that often happen. It runs an SQL query that accidentally deletes a random row or like a random value from a random team. And it will say, I am very sorry. I accidentally ran that command. But by using row level security, you are effectively making the entire table invisible to that agent. It's impossible for it to like accidentally run and delete things. I actually have a lot more example here. This is a open source repo. You can find it. It's attached to my talk slide. I'll show you guys later. Now, the whole idea is now all the reads, writes, and joins are protected. So you give a initial team ID, app ID, or whatever ID to the agent, and from then onwards, it's impossible for that agent or any other AI tool running to make any damage. So RLS is already a very good way to build apps, but with AI and agentic apps, RLS has a special advantage here. Next, has anyone tried Supabase? I think I already asked this question. So the most important thing about Supabase is how it makes the entire app development process easy. Correct? Who and all here like Supabase a lot? Not just use, but you would say like 10 out of 10, I will always use it. Who's here? One? No one else? 2%. What happened to others? Maybe. Why? Good one. Tell me why you are like hesitant to use.
I mean, like, no, not hesitant. It's the only thing I'm using right now. Not expert even on.
Okay, you are only been using Supabase. So you are like wondering, is that the right approach? Would be nice if someone can tell me why they wouldn't use Supabase. Would be a nice segue into my next topic. Okay, in that case, I'll tell you, most of the people who use Supabase are worried about getting vendor logged in. So the idea is right now for like starter or like initial small traffic application, Supabase is an excellent plan. But as your traffic and number of users grow, they are like worried about bill, like what would happen, how much Supabase platform will start charging me. You are worried about that?
Yes,
Always?
because the plans are there is a pro plan that is for $29, and there is a Teams plan that is for $999, which gives with all the certification and all. And even with that, I am very reluctant to use Supabase. And even any client that I am working with, Supabase is very new to this industry, and the data application you can host. Most of the people are hesitant to store stateless applications in AWS. Most of the people are hesitant to use AWS, and they were going with GCP that they are very friendly with, or else their tools are very friendly with. But we do not know how the Supabase works and what are the policies of the Supabase, and how the replicas of the super data is being stored.
Okay,
and,
okay.
How is it managed? What is the SLA time to get it up and running? It is very hard.
Got
In
it.
AWS, it is very easier And Postgres, it is built on Postgres itself, and I'm having an access to the Postgres directly. It's just a wrapper on top of the Postgres. So why to pay?
Yeah. Actually, all of them are valid points because just for Postgres, you are actually getting vendor locked in one. You don't know the kind of policies to expect, and they have a 999 plan plus usages. You don't know what kind of usages your apps is gonna receive as well. Luckily, there are actually tools that brings Supabase like experience into your regular Postgres, and these are like actually very simple to work with because first tool I like is PostgreSQL. So what it does is you give your existing Postgres URL to a command line tool called PostgreSQL, and it immediately converts your entire database into a REST API. If you think about it, that's kind of what Supabase also does. It gives you an open API endpoint to your application. It also gives you like functions and everything. So PostgreSQL with row level security takes care of the authentication part because the team ID I was setting before, right? PostgreSQL actually accepts it as a JWT token. You set the team ID, user ID, or everything inside a JWT token, give it to PostgreSQL. It will pass that to the RLS. So your RLS knows what table you are working with. And even more configurable is PostgreSQL. So what PostgreSQL does here is it gives you a GraphQL layer on top of your database. So what happens is everyone knows GraphQL, right? The basic concept. You only query for what you want. So now you query for what you want and it converts it into PostgreSQL queries with the correct select, where, and all these clauses. And it also adds the RLS authentication as well. So you get a completely end-to-end well-typed REST endpoint and GraphQL endpoint. So basically, you can get Supabase like developer experience using full open source tools. You just have a Postgres table, have one more node process running somewhere close to it. You get the REST endpoint and GraphQL endpoint, and there is also more tools like this. I just picked the two most popular. Yeah.
Currently, self-host Supabase. It is open source.
Yeah, good luck with that. I tried. It has been like a huge challenge, self-hosting Supabase.
I mean, I've been using Supabase self-hosted for like the past.
But you running it locally makes sense. But self-hosting means you have to bring all those hosting resources over. Here, if let's say I am using PostgreSQL and Postgres table, it's just one database and one node process. That's it. If you have to self-host Supabase, how many modules do you have to host?
I mean, there total, I think 8 microservices.
Yeah.
The RAM requirement is 4 GBs only.
It's kind of actually hard hosting all of them and making sure all of them stay up to date. But here you can pick and choose what you want on top of it. The next interesting part about Postgres is the way it stores data. So, like I told you, AI apps create both structured and unstructured data, which means you have like well-defined tables, and sometimes you will have huge JSON dumps. For example, the tool calls, reasoning text, all this, and sometimes even random logs and other files that you want to store. So the beauty about Postgres is it doesn't differentiate between these data. It just makes everything queryable and easy to access. So all JSON data inside Postgres becomes a data type called JSONB. And this JSONB is sub-queryable, which means just like how you can query your JSON value inside MongoDB, you can query it in the same way within Postgres. So you want to like do any kind of filter, join, or aggregate. These are like normal SQL operations. But if you want to do nested operations on JSON, this gets a lot more interesting because you get special operators which will let you pick and choose which JSON data you want to like query from. Actually have few examples here. Let me quickly get those. Yeah. So first let's see what data we are working with. So I am actually getting path and metadata from the files table. Okay, so this is the path and this is the metadata. So the page.tsx exports a default one. Middleware exports auth middleware. Schema exports user teams files. Okay, it's just taken some of my drizzle code and I have a metadata JSON here. Now, if I want to pull a JSON value out as a text, okay, Postgres comes with this interesting operator, which basically like tries to get to the LOC JSON data out from the table. So LOC has like 22 or 28 count here. So let me add this. You can see I have the file and the lines of code within that file directly as the response. So instead of having like one JSON data here, I have a sub table here. This is technically a Postgres table. Now I can do sub queries here, which has all the lines of code extracted out as a structured data format. And I even have more examples here. For example, if I want to get all the values where the export users is present, I have another operator. It checks what's within a JSON array. So if I say find all the files that have users in their exports, it finds the schema file. It has users, teams, and files. So you can work with unstructured data just like how well you work with your structured data because of the JSON-B. Next, the queues. So how many people have built queues before here? 2, 3. What do you use?
Active queue or RabbitMQ and Kafka.
Kafka, RabbitMQ.
Even Postgres has support of queuing.
Yeah. Postgres queues are actually just tables with like locks. So idea is you skip the update for a locked table row, it automatically starts behaving like a queue. It waits till the lock is unlocked. So you have like 5 operations about to happen on like one row, you just lock the row. So the 4 operations will start to wait. And the beauty is once each operation is complete, you get a notify update. So you get real-time response back saying, hey, this operation is complete. So your UI can also update in real time. And the fun part is it's completely inbuilt. So no need to like install any extension or like any other tool. You can just write some queries and you have the queue functionality ready inbuilt with Postgres. And there is also an interesting extension called pgcron. So you basically install this extension using create extension command. What it does is it lets you execute Postgres functions as cron jobs. So Postgres function is a pretty big topic on itself. Basically lets you write SQL functions and give them a name. This pgcron will make you execute those SQL functions directly as cron jobs. So you have queues, you have cron jobs, but what if you want even more? You want like even more reliable jobs with like status tracking, failure, just like RabbitMQ or Kafka. You need that level of performance within Postgres. You can actually get something called GraphFile Worker. So GraphFile Worker is an open source project built by the team who built PostgreSQL, and it basically gives you a Kafka or like RabbitMQ level queue support with all the user experience directly on Postgres. And this also is like one more node service that runs along with your Postgres table. So your table still remains the core database, the data store, and all the other operations are like small tiny services that just runs parallelly along with it. And the interesting part about GraphFile Worker is now instead of writing SQL functions, your queue and jobs are now JavaScript functions, just like how Supabase functions work. You write actual JavaScript code and you assign it to queues, you assign it to cron jobs, and suddenly like you have all the benefits without any fancy setup. And I was able to like use all of this with like one simple project. And once Claude read this, it was actually able to follow and build on top of this immediately. So using it with the vibe coding agent is also very efficient because it's just natural for them to learn when the queue and the table are next to each other. Next, it's a super important topic, which is RAG. Can someone explain RAG for me? Yes. Can some? Yeah.
It's like retrieval augmentation generation. What does that mean is like we can provide external source of data to whether that is what this RAG concept solves actually.
Okay.
Like LLM can generate tokens. It doesn't have a context of what we have as documents in our company. So we can feed that documents with the RAG system. So RAG will have a embedding layer and stuff. Based on that, it will create own embeddings. From that, it will retrieve onto the generation part.
Yeah, exactly. So basically, whenever you want to give some additional information to your AI agent, you have to build a RAG system, which kind of like runs before the agent runs and tells it, hey, you might find this information very useful before you start working. And since you built RAG, which stack you used to build RAG on?
I don't get the time to build. Like I'm a full stack developer.
Okay.
I have a lot of prefix to fix. So I do POCs basically.
Oh.
Like I have a couple of juniors. They are actually working on this RAG system. They use a couple of Python packages to build this. They were speaking about some vector DBs using that they will store semantic embeddings and
Got-
very technical these days.
Got it. Pinecone, all those vector databases. So those vector databases use cosine similarity or nearby matching to get the appropriate data. Now, if you ask me, whenever I build RAG, there are two important things. One is how good your text search is, how good your vector search is. Because text search will let you quickly find direct matched items. Then vector search will find similarity matching items. And the best part about Postgres is that you can build the entire RAG as your additional table within Postgres and you are done. And I'll actually show you guys how it does. So first, what we have is an extension called PG vector. So what PG vector does is it creates a new data type within Postgres, and this data type is an embedding data type. A vector is just an embedding. So any embedding you create from within an AI agent like AI model, like OpenAI model or Claude model, you can store those embeddings directly into the table now. So actually this is SQL heavy. I think I better show it directly as a demo. Let's see. I have a search example here. Yep. I already have the table open. Good thing I ran once and I just kept all of those in the markdown file, so I don't have to like write this again on the stage. Cool. So I am searching in files. So what I have is I have the path, the language, and the length of the content. So let's see what the table looks like. So I have the page.tsx, which is a TypeScript file, 313 bytes. So like that, I have like 5 different files within my repo. Now what I'm going to do is first the text search. So for using text search, we are using an extension called a TS query. So it uses a function called a TS rank. So what it does is it tries to match the phrase, like how much the word within that plain text is matching well, and it gives us a similarity. For example, let's say I am searching for JWT and session. JWT a word and session another word. Which files within my code base contains these words? So this is RLS. I am setting the team ID. Then I am selecting which columns it should look for. So let me just copy. Add it here. And if you look at it, I am searching for JWT and session. It exactly found the middleware.ts file contains the words JWT and session within them. This is because I am already like indexed the text content with TS vector. So now you have the plain text search working here. And if I want to get even more detailed, like I have the gin index enabled on the TS vector type. So now what I can do with this index is I can actually create markers on matched strings. So let's say now I am searching for server component, English term server component. Since I have the index ready, in the result, now I will have marker which is a B tag around the text that has matched. So you can see server component is in page.tsx. And in the response, you will see server has a bold around it, server and the component. So with this search, if you are displaying this info on your UI on HTML, you can automatically highlight the matched strings. So this is plain text search within Postgres on a Postgres table without any external plugins. This is just internal indexes. You get a full-on search powerful enough for most of your use cases for RAG. Now, the next one, however, is vector search. So this one uses embeddings. So when I created this table, I already added some embeddings here, not very accurate, but something that would work well for the demo. I pre-created certain embeddings and added it to the database. So what it does first is a similarity search. It just checks if I am looking for all the files that match the middleware. What are all the source files that are very close to the content of the middleware.ts file? And this is the ordering logic. It just uses the distance, cosine distance, and picks the right one. So let me quickly see how the code files are similar. With this, middleware file is the file that I was searching for, so it has absolute one similarity. But all the other files, schema file, the Rust file, they all have like decreasing value of similarity. So this similarity search is basically what the vector search is all about. You use like special vector databases and other tools to achieve it, but in Postgres, it's just one other extension called a PG vector extension. You install the extension and you immediately get all this vector search functionality within your database. I actually built a even more complex query which basically like uses both plain text search and vector search to show you like how I can build a detailed similarity for authentication middleware. I am trying to find I want to see which code contains the authentication middleware. I don't know where it is in my code base. So I just take this command, run it on SQL. It basically uses a text search and the vector search and assigns a rank to all the matched files. With that, you can see the authentication middleware is highly likely used in the page.tsx because that is where we write the authentication check at. So you get a nice performant RAG retrieval, and if your AI agent needs to know where to look for within the code base, it can use this setup to order which files it should prioritize, and it can look for the right data. So the idea behind this setup is now your AI agent has pretty much all the necessary items. Like you want to create a job queue, you want to have RAG retrieval, you need strict authentication. You kind of got all the infrastructure within like one Postgres table. If you want to run it, it's just like one Docker Compose file and you immediately have all the necessary things. And they also work really well with tools like Drizzle and all. You can write all these SQL files with the typed migrations and everything. These are all I already showed via the demo itself. Next is notification. So this is for real-time info. Like I said, when a job finishes and you want to let your UI know that a specific job that was running in background is complete, or like any real-time update you want to show to your users. For example, two people are texting with each other, you want to immediately notify the other person a message arrived. So Postgres comes with a system called a PG Notify. So what it does is any update or any change that happens within your database, you can set a trigger. So it will automatically start calling a certain function or a certain endpoint whenever the change happens. If you are looking at Supabase real time behind the scenes, this is how they have built the entire real time server. They have added a lot of optimizations obviously on top of Postgres. But for your app, you get full real time triggers directly within Postgres, and it's usable today. Pretty much all of these are like pure SQL code. I think it's better you guys like get this presentation and the sample app I have and try this by yourself. Let's lastly look at how React comes into the picture here. So far we have been working on the Postgres side. You have the database ready with all this functionality. Now what you need is a nice UI on top of it. And luckily React Server Components, what it does is it lets you access database directly on the UI level. So you have the inbox function here. I think the code is little too slow. So if you have Drizzle or any other Node.js function that can query the database on the fly, it can directly access the info and pass the value directly to your user interface. So React Server Component works really well here. And if you don't like React Server Components, because even recently I'm seeing a lot of exploits and stuff happening, just go with plain server rendering. That also works really well. Now you don't have to worry about building APIs. You can directly access the database via server rendering. Or if you do want to use APIs, you can just connect with it like PostgreSQL or PostgreSQL. You get the entire API layer as well. So this is basically the summary of everything we have discussed so far. I think I made the text a little too small. Let me see if I can zoom in. No, I'm unable to zoom in. Cool. First, basically, we spoke about like 8 different things. I just summarized them into 5 here. Auth, when it's in Monolith, you use middleware checks. If it's a microservice, you use claims across multiple services. You create a JWT token, make sure all the claims are passing. But on Postgres, it's just one row level security. You create a table with a specific rule and make sure everything is secure across. And vectors, you need specialized tools for both Monolith and microservice. Postgres is just one extension. You install PG vector and you immediately have the entire vector DB functionality. Likewise, for real-time jobs and UI, you have inbuilt functions that are ready to use directly with the Postgres setup. Cool. But big disclaimer here, Postgres can do the 10 jobs really well, but doesn't mean you have to use this for the job forever. Because obviously, when you are scaling, Postgres scales really well. I'm not going to say it's a difficult to scale platform because Postgres is transacting like trillions of rows and columns of data in production today, and it scales really well. But that doesn't mean you have to rely on this setup all the time. There are times where you will have to expand out. You will need special microservices, special containers for certain jobs. In that case, feel free to move away from it. But when you are building on the agent level or you're creating a new application, I'd say this will basically like give you a huge boost in terms of building your application, getting started. And if you are anyone's doing POC in your team, feel free to pitch Postgres as your new POC platform. Cool. So for small teams, solo developers, the best AI stack is often like one simple database that you can work with. So now I'm open for questions. Anyone has any questions, feel free to ask now. Yeah. Mic is coming.
Hi. Where do you host the Postgres database you're talking about? Because it's open source, right? Like, where do you typically host when it comes to enterprise?
I host it in Hetzner. personally. In enterprise, you just use any cloud provider like Aurora, Postgres, or like Planet Scale Postgres. Fly has an amazing Postgres service. You can use that. It's up to you. Now that your entire infrastructure relies on one simple Postgres table, hosting it is actually very easy.
Virtual machine on-prem or to do. There are managed databases available from Aurora is available, Azure has GCP has a variant. So if you want to take away all your database operations away from you, you can just use the managed database that is available in hyperscalers. Or if you have a team that that can scale and operate, you can use any company.
You can give the mic to him.
But is it actually an enterprise grade database that we can use? That's my next question.
Postgres.
Yeah.
As far as I know, Postgres is the enterprise grade database out there.
If you're benchmarking with Oracle and SQL Server, there is a norm that, because Oracle and SQL Server are always counted to be the enterprise type of thing. But things have changed in the last 15 years. There are a lot of companies new age tech companies use Postgres. Google uses Postgres heavily. Netflix uses Postgres. So, a lot of new age companies have used Postgres.
Yeah, so Postgres has matured into a pretty enterprise grade database now. You can blindly go for it any day.
Thank you.
In fact, you have shared a deep knowledge on Postgres. In fact, I was earlier getting frustrated with Postgres actually.
Oh.
I prefer MariaDB. Okay. I think you shared many plugins regarding Postgres. Is there any other set of plugins which are more useful for day-to-day apps?
Okay. So there is this repo called Awesome Postgres. You can go there and you will find like huge list of plugins for different operations. There are like plugins for running AI agents and all directly next to Postgres. You can refer to that repository, Awesome Postgres.
Awesome Postgres.
Yeah.
Okay. One more question is that the main reason for Postgres getting frustrated, right? In Maria MySQL, right, with a single user, you can give multiple user ACLs in multiple databases. For example, user A should have read-write access in database 1, read access only in database 2. We can have this flexibility in Maria MySQL.
Okay.
So, do we have similar flexibility in Postgres? Same user, different ACL in different DBs.
We have, technically a user can have multiple database accesses. I'm not sure, because you are asking now, I am questioning myself, does it have that?
The main reason for frustration is that, right, whenever you use Postgres, right, a user can have access only in single database.
Not sure,
Single
maybe
database
you can answer it better.
Single database can have multiple users, but user is mapped to only one database. Totally explains what I have used
Okay.
Postgres.
Friend is eager to answer.
Actually, I have recently set up a new app. Recently shipped the company, and I am setting the Postgres recently. And a user can have from a granular level to multiple databases and to the granular level of tables as well.
Okay.
Now I am just seeing that the user can have on a row level as well. But till table level, I have set it up. So I have different applications, and every application user that I am setting up will have access to only certain tables in different multiple databases as well. So that is possible.
So single user can be mapped to multiple DBs and tables.
Multiple DBs and tables as well.
The only real limitation is you can connect a single user can connect to a single database. Connect to only one database in a single connection. Per connection, a user can have only one database.
Oh.
That is the only real world constraint in Postgres.
Okay.
Technically, you can have multiple things. So teams that generally have this need, what they do is they open multiple connections, or they use something like pooled connections.
Okay. So here, right, when I use MySQL for application usage, right, I make a connection with one DB1. Okay. But when I query with the select star from db2.table, it gives the results in MySQL and MySQL connection. So as you say, it won't work in Postgres, right?
Yes. on the trade-off that your team is making for the data access patterns that you have, right? Because technically, cross DB joins are anyways going to be expensive.
I'm not speaking of join. Okay, just a simple select row. For example, right, user main app will be main DB, the analytics will be in separate DB.
Alright.
Okay.
Then I think, the real world, what people do is they open a new connection to the new view. That's it.
And one more thing is that, right, especially Postgres, right, I maybe speak negative of Postgres, but this is a problem which I prefer MariaDB actually. So when we take a dump of a Postgres DB and try to restore it, right, especially the auto increment ID, the column, okay,
Yeah.
the sequential ID, okay, do you face this DB roster problem ever?
No, I usually haven't restored database that much, and I personally use UUIDs for the IDs,
Okay.
not incremental IDs. But I think you might have answer. Okay. I haven't restored with increment IDs, but I don't think it would be a problem today because a lot of people do backups and restores often.
The thing is that, right, when we try to restore the dump in UDB, right, after restoring the tables, we actually to write one more set of commands for each table to reset that ID.
Oh,
Okay, this is one of the flexibility available in Oracle and Maria.
okay.
Okay.
It is a problem. It is a real problem. Postgres has multiple ways of taking backups, including PG down. None of them solve this auto increment problem. Counterpoint, you should ideally not use auto increment.
Yeah.
But those are legacy decisions, and sometimes you cannot make those decisions. So that's when you are ultimately you continue using MariaDB or MySQL.
Yes.
If it works for you, then why not?
Okay.
This is ideally, I would say, this is one of the reasons, many reasons why people avoid auto incrementing IDs because of this.
Yeah.
Many databases have this problem. I've run into, and even in MySQL, depending on the storage engine, it would still be good. If you're using EnoDB, fine. But if you use other storage engines, this problem, I've seen that happen in production because I used to work on MySQL for a very long time. So we've had this problem also. That's why we use non-incrementing ID, something like a
Yeah, I by default to UUIDs. So I never faced any problems with restoring dumps yet.
Okay. Last question there. Other than PG admin, right, is there any other GUI tool which is more user friendly for accessing the DB?
Yeah, there are plenty of tools. We have Beekeeper Studio, DB Weaver.
Beaver, no, not Beaver. Any other?
Just go to that awesome Postgres. You will find plenty of options. I personally use Beekeeper
The
Studio.
thing is that, right, there are a couple of GUI tools what I use. Okay, nothing is lightweight actually.
When you say GUI tools, right?
Prisma. Okay. Have you ever used Hades SQL?
No.
Heard about it? Okay,
Haven't
that's
used.
a very much lightweight tool. Okay, it loads faster. For Postgres, right, you can use it for read operations. It works perfectly.
I primarily use the PSQL shell itself. It's
For hard developer, code developer, it's okay, man. Okay, fine. Yeah, thank you.
try Beekeeper Studio. It's really good.
Okay, last question. As you said, right, we have multiple engine types in MySQL and Maria, right? I think there are very few engine types, right, in Postgres.
I never set the engine type in Postgres before.
Yeah, once I try to explore, there are only maximum 2-3 types. Not even, okay.
I don't think engine type is a thing here. We have to check. Because Postgres, we just set up the database. That's it. Never set any configuration for engines before.
Fine. Okay, do you have any experience with the Postgres of
I think
handling with thousands of, not at least a few GBs of data, 10, 20 GBs of data, whatever?
not 10, 20. I worked with like 200, 350 GBs and all
Okay.
with Postgres.
So it works fine for you.
Yeah, that's primarily why I use shell to query the appropriate info quickly. I think others also have few questions.
Yeah, sure, but that's it.
Is there a embedding model in PG vector?
Yeah, you can set the custom dimensions. Yeah. Model is something you pick on the application side, because you create the embeddings outside and you bring that embedding back into the database.
So the onus is on us to do the embeddings outside and bring it in.
Yeah. Or there are plugins that does the embedding directly within the database. I didn't cover those plugins here.
So let's say if I want to use a sentence transformer or
Yeah. You can.
I do it outside and then. So we do the embeddings outside and then we.
Yeah.
So we can do it.
Yes.
Yeah, so excuse me. To answer your question, we can't use the embedding model and PG at the same instance because one is the embedding will most likely be a GPU for you. So and Postgres are mostly CPU heavy, right? Yeah.
But
Yeah,
you can make the API call.
I can make an API call, but making both on the same instance won't make sense because good GPU instances will not have a CPU trade-off. Right? It's like the memory versus the classical Caption trade-off. So
You have a transformers like sentence transformers.
But the embedding models you ask like for 700 dimensions. But the problem is you will have that even if it's CPU running, right, then your Postgres won't have bandwidth to track it. That's always a problem.
First of all, thank you very much for the talk, which was really useful on knowing how Postgres plays a big role on full stack applications. So my question might not be within this talk. This is totally different. Not totally, but this lies within the full stack. I have recently came up with a project which is known as which is like a self-healing API. Which works with an AI agent and recovers your backend services when it fails. So simply this is how it works. For example, let's take the client requests something. That request will go through a gateway that will have an authentication validation. After that, if that is not suspicious and that is being authenticated, it will be forward to the next step. And if it doesn't, it will fall back to the error handling, like the authentication responses of forwarded or something like that. And let me come back to that stage where it forwards. So when the request is being forwarded, if the request goes and fails on the backend services, like if the backend services fails, I'm implementing a recovery engine right there. A recovery engine where our backend services will restart to route the request again and process it. Or else, if it still fails, fall back to the normal responses.
I think we should do it as a networking discussion here.
Yeah, I'm like putting up right here because there are a lot of senior engineers I care, which have probably worked within the industries. I want to know what could be the blockers I would get when I implement this. Like for example.
Sorry, I think we can do this after the questions are done. We'll use one-on-one. Is that okay?
Okay.
Yeah.
Thanks.
Yeah.
So I have been using Postgres for quite some time, and thank you. I mean, a couple of extensions I was not aware of, but I have used some extensions like JSON-B extensively. And coming to the question that we have multiple connections and we won't be able to connect. In fact, for that also we have an extension called as db-link where we can connect multiple queries. So I have used that extensively. But one of the experience that I have is when I use extensions, some of the extension at a scale works really well. Let's say you mentioned about PG vector and PG query, right? So in the same way, even 7 years ago also we had something called as PGPRM where we used to do full text search, cosine similarity search and all. And that was working really well. But some of the extension like JSON-B, when I'm doing the query, the JSON related query for millions of records and all, it's really choking, like it's really difficult to do the queries. So is there any caveats or we should be aware of before using an extension?
Okay, so JSON-B is actually not an extension, it's an inbuilt data type. And the query part of the JSON B hugely depends on the type of index you are creating. So let's say you want to query like certain nested values within the JSON. You can kind of destructure and store it separately. That would automatically like make the query efficient. Or you can find an appropriate index or like multiple indexes that will make your query faster. So the idea is you have to kind of optimize it well. You can obviously store the entire JSON data, but that doesn't mean that's the only way to like store and handle the data. Depending on your scale, depending on your need, it's better to try different approaches, both in like storing and the querying process. It's a trial and error once your scale starts to like grow up.
Same goes for extension.
Yeah, same for extensions. Yeah.
So you have you said about there is a vector storage as well that is available, right?
Yes.
So how comparable it is? Do we have any experience? I did not work with the PG vector to store the databases anywhere. So the quadrant, and you have Python as a quadrant, is an open source, just like the Postgres that we have.
Yeah.
And it is meant to store only the vectors that is available. So how comparable it is that I store the vectors in the Postgres rather than going per quadrant, if you have any experiences with that?
Personally speaking, PG Vector is really performant. And right now it is backed by Supabase, I think. They personally use it within their platform itself. So they are optimizing it really well. And so far I haven't noticed any bottlenecks doing like a properly indexed similarity search with PG Vector. But there are caveats with all of these complex data types. Like the way we are storing them and the way we are accessing them, we have to pay attention to the index and the size occupied by the index and all of this. But one immediate advantage you get keeping the embedding directly in the same database is that your latencies will greatly improve. Because previously you have to hop between two databases. Now both are within the same database, and in a single query all the data is coming back. It will greatly improve the search latency for your users. So there is an actual advantage keeping it directly within Postgres.
So that means that you are storing the vectors in a different table or in the same table as a separate column. Is the vector being stored? If the vector being stored in the same table in a different column, then my read and update operations that I have indexed on might get affected because I am doing an embedding and then storing the data rather than just putting the transaction in the Postgres.
You kind of have to be smart about it, because you can keep it in a different table or you can keep it in the same table in a different column. But how you are updating, you have to be a bit smart about it. You can update the data immediately, give the response to the user, and create a separate queue that will on the background generate the embedding and store it. That will give a good user experience. But if you block the user while the embedding is being generated, that's ultimately a poor experience for the user. So it's about how you design. Any more questions? Yeah.
Just to add, the ideal design would be to keep your vectors and your regular tables separately. You should have it separately. That helps a lot. You can have a bit of metadata in your vector store. If you keep it in a separate table, you can have that metadata filtering that like he pointed out. I think when you're doing the ingestion, it helps you to segregate, do the transaction first and then doing the embeddings as a synchronous process. That helps a lot. So another question for you. So we talked about a lot of plugins here.
Yeah.
So one of the challenges for me is to heading into the CISO, okay, where they find a lot of vulnerabilities in using these plugins. How frequent is this, the updates on these plugins, okay, in case there is a 0-day vulnerabilities that happens, okay, how helpful they are, how the community is responsive with specific to these plugins?
So this is actually depends on the plugin maintainer. So at the end of the day, these are all like open source projects. So if they are backed by a huge team like Supabase backing PG Vector, you can expect timely updates. But if you are using a plugin that's like maintained by one poor guy who has been working on his free time, it depends. You cannot like guarantee that. But Postgres itself is solid. They address all these vulnerabilities and updates fast. So you have to be a bit smart about choosing the plugins that you are adding to your database.
So actually, we're talking about the RAG vector retrieval, right? Okay. So there's nowadays these are also like graph retrieval, knowledge graph retrieval. Is there any kind of associated plugins or any of those types that works with, along with like already it's doing a hybrid, like you doing a text search
Yeah.
as well as a vector search. Is there a graph as well? Graph based search?
Might be. I haven't tried graph search personally, but I'm sure someone would have tried, or you can build a graph plugin yourself. The plugin ecosystem is open. So,
I think no other questions.
yeah. All right. Thank you all. You can.
Last question can we take?
Okay.
So the plugins that we are installing, I hope that installations is very seamless in the open source when we are maintaining and doing it on our own compute, whether it is an EC2 instance or in on-premise servers that we have. But does this same plugins will work efficiently with the cloud providers, and how seamlessly how we can install these plugins?
Most cloud providers make sure plugin installs are seamless, just like how you do in npm install. If you are deploying it in your custom cloud, which has policies that blocks plugins, then you will have to look out.
Most of the cloud providers that I mean that AWS.
Yeah, they are all pretty seamless. They make sure plugins work. Right? Any questions? I'll be here. You can like take it off now.